Welcome everyone to TLC Math Made Easy. This video is all about parallelograms and its properties. So at the end of this video, you should be able to determine the conditions that make a quadrilateral a parallelogram and use the properties to find measures of angles, sides, and other quantities involving parallelograms. Now let's look back at the definition of a quadrilateral. A quadrilateral is described as a four-sided polygons. The sides of a quadrilateral are segments or line segments, and the endpoints are vertices. Now let us take a look at the quadrilateral EGIH. This is a quadrilateral since it has four sides: the side EG, the side GI, the side IH, and the side EH or HE. The vertices are the endpoints of the quadrilateral. So we have the endpoints E, G, I, and H. So therefore, the vertices are points E, G, I, and H. Now we have also two pairs of opposite sides. So which are the two pairs of opposite sides? So EG, which side is the opposite of EG? So EG, the opposite side is HI or IH. For GI, its opposite side is side EH. So we have side EG and side IH, and then we have EH and side GI. So segment EG, segment IH, segment EH, and segment GI. How about the two pairs of consecutive sides? Adjacent sides, two pairs of consecutive sides. So we have side EG and side GI. We have also GI and side IH. What else? It could also be EH, side EH, and side HI. And then we have GE, side GE or EG, and side EH. So there are four pairs of consecutive sides. We have GE and EH, EH and HI, HI and IG, then IG and GE. How about the diagonals? Diagonals are this: segment EI and segment GH. So we have EI and GH. Next, two pairs of consecutive angles. So what are the angles here? The angles are angle GEH, this angle EHI, angle HIG, this angle, and angle IGE, Now we have two pairs of consecutive angles. So the two pairs of consecutive angles are, it could be angle GEH and angle EHI. It could be angle EHI and angle, we have EHI and angle HIG. HIG. What else? We also have, so I have to write it here, EHI and HIG. We have HIG, angle HIG, and angle IGE. It could also be angle IGE and angle GEH. So those are consecutive angles. GEH and EHI, o magkasunod na angle yon. HIG and IGE. Next, two pairs of opposite angles, magkatapat na angles. We have angle GEH and aning katapat na angle ng angle GEH. Angle GEH is here, this angle. So ang katapat niyang angle ay ito. So we have HIG, angle HIG. We also have angle, how about angle EGI? Angle EGI and angle EHI. Angle EHI can also be named as angle IHE. Angle EGI can be also named as angle IGE. Now, what are the other names of the quadrilateral aside from quadrilateral EGIH? So we can name that also as quadrilateral HEGI or quadrilateral GIHE. What else? Quadrilateral IHEG or quadrilateral EH, or it could be quadrilateral EHIG. So there are many ways on how to name this quadrilateral. There is a special kind of quadrilateral, and that is what we call the parallelogram. Now, what is a parallelogram? A parallelogram is a quadrilateral with two pairs of parallel sides. So, if this is parallelogram ABDC or ACDB, then the two sides, opposite sides, are parallel. So, we can say that side AB is parallel to side CD, or side AC is parallel to side BD. When are two lines parallel? We say that two lines are parallel when these lines do not intersect or do not meet, no matter how far we extend this line. So, segment AC and segment BD do not intersect. AB and CD also do not intersect. So we have AB or AC is parallel to BD, and AB is also parallel to CD. When is a quadrilateral a parallelogram? Let's take a look at the conditions that make a quadrilateral a parallelogram. Let's take a look at quadrilateral ABCD. If you look at the sides AD and side BC, what can you say? So we can see that AD is congruent to side BC, or AD is congruent to side BC, or they have the same length. Can you also say that side AB has the same length as side DC? By looking at the picture, we can say that side AB is congruent to side DC. So we can write that as AB, or side AB is congruent to side DC. So condition 1 states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we can say that quadrilateral ABCD is a parallelogram. Next, second condition. By that definition of a parallelogram has two pairs of opposite sides. We can say that AD is parallel to side DC. And by condition 1, we also said that side AD is congruent to side BC. So we can write that as AD. Side AD is parallel to side BC, and side AD is also congruent to side BC. Condition 2 states that if one pair of opposite sides of a quadrilateral is congruent and parallel, then the quadrilateral is a parallelogram. Based from the measurement that I got from the GeoGebra app, the measure of angle A is 135 degrees. The measure of angle B is 45 degrees. Measure of angle D is 45 degrees. And measure of angle C is 135 degrees. If we take a look at the opposite angles, angle A and angle C, we can say that the measure of angle A is 135 degrees and measure of angle C is 135 degrees. And we can say that angle A is opposite angle C. So therefore, we can say that angle A is congruent to angle C. Angle B, or measure of angle B, is 45 degrees. And measure of angle D is 45 degrees. So we can say that measure of angle B is congruent, or angle B is congruent to angle D. Condition 3 states that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So therefore, quadrilateral ABCD based on their angles is a parallelogram. And then if we take a look at the measures of the angles of the quadrilateral ABCD, and we take a look at the measures of the angles of the consecutive angles. Let's say angle A and angle B. These are consecutive angles. If we want to add the measure of a pair of consecutive angles, let's say a measure of angle A plus measure of angle B, what do we get? Alright, if we add 135 degrees and 45 degrees, the answer is 180 degrees. If we add also measure of angle B and measure of angle C, again the answer is 180 degrees. Measure of angle C plus measure of angle D is also 180 degrees, and measure of angle D plus measure of angle A is also 180 condition 4 states that if two consecutive angles of a quadrilateral are supplementary, then the quadrilateral is a parallelogram. So if we add the measures of two consecutive angles and their sum is 180 degrees, then the quadrilateral is a parallelogram. Next, if we take a look also at the diagonals AC and BD, and these diagonals intersect at point E. If we take a look at AE, the measure of AE is 1.8, the measure of EC is 1.8, the measure of BE is 4.3, and the measure of ED is also 4.3. Then we can say that the diagonals of the quadrilateral bisect each other. So, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And the last one, the last condition that guarantees that a quadrilateral is a parallelogram. If we have the quadrilateral ABCD and we have the diagonal AD, we can see that there are two triangles here, triangle ABC and triangle ACD. We also know that if this angle or this side AB is congruent to side DC, we can also say that AD is congruent to side BC. Angle B is congruent to angle D. And by the SAS, side, angle, side, we can say that the two triangles, triangle ABC is congruent to triangle CDA. CDA. The other diagonal BD also divides the two triangles into two congruent triangles. We can say by the SAS also, side angle side, we can say that triangle BAD is congruent to triangle DCB. The last condition states that if each diagonal of the quadrilateral forms two congruent triangles, then the quadrilateral is a parallelogram. How would you know whether or not a quadrilateral is a parallelogram? So by definition, a quadrilateral is a parallelogram if it has two pairs of parallel sides. We have also discovered the following properties of a parallelogram. 1. Opposite sides are parallel and congruent. 2. Opposite angles are congruent. 3. Consecutive angles are supplementary. 4. Diagonals bisect each other. And 5. Each diagonal separates the parallelogram into two congruent triangles. So we will be using these properties of parallelogram in solving for the side, the angles, or other quantities that involve parallelogram. Example number 1. problem number 1. Given is quadrilateral ABCD is a parallelogram. If AB is 5x minus 8 and DC is 3x plus 14, what is the length of segment AB? So let's write the given. AB is 5x minus 8 units and DC is 3x plus 14. So by the property of a parallelogram, opposite sides of a parallelogram are congruent. Since sides AB and DC are opposite sides, then we can say that side AB is congruent to side DC. Therefore, the measure of side AB, which is 5x minus 8, is equal to 3x plus 14. So, by manipulation, we have 5x. By the addition property of equality, 3x becomes negative 3x equals 14. Negative 8 becomes positive 8. So, 5x minus 3x is 2x. 14 plus 8 is 22. By the multiplication property of equality, to solve for x, we multiply both sides by 1/2 or simply divide both sides by 2. So, x is equal to 22 divided by 2 is 11. So, x is equal to 11. The question is, what is the length of AB? Since AB is equal to 5x minus 8, so we just substitute x to 11 to x here. So we have AB, or the measure of AB, is equal to 5 times 11 minus 8. And 5 times 11 is 55. 55 minus 8 is 47. So therefore, the length of side AB is equal to 47 units. Next. Again, the given is quadrilateral ABCD is a parallelogram. If measure of angle A, let's say measure of angle A is 5x plus 38 degrees and measure of angle C is 3x plus 50 degrees. Solve for measure of angle A and measure of angle D. So what can you say about angle A and angle C? That's right. Angle A and angle C are opposite angles. So therefore, angle A is congruent to angle C. Since they are congruent, their measures are equal. Angle A is 5x plus 38 degrees and angle C is 3x plus 50 degrees. So by the addition property of equality, we have 5x. 3x becomes minus 3x. Then we have 50. Positive 38 becomes negative 38. 5x minus 3x is 2x. 50 minus 38 is 12. So, divide both sides by 2 to solve for x. So, therefore, x is equal to 12 divided by 2, that is 6. Now, we are to look for the measure of angle A and the measure of angle D. Since measure of angle A is equal to 5x plus 38 and x is equal to 6, so we have 5 times 6 plus 38. So measure of angle A is equal to 5 times 6 is 30 plus 38. So therefore measure of angle 6 is equal to 68 degrees. So this is 68 degrees. And measure of angle D, since angle A and angle D are consecutive angles, then we can say that measure of angle A, or angle A and angle D, are supplementary. We can say that the measure of angle A plus measure of angle D is equal to 180 degrees. And measure of angle A is 68 degrees plus measure of angle D equals 180 degrees. By the addition property of equality, then we can get measure of angle D 180 degrees minus 68 degrees. So therefore, measure of angle D is equal to 180 degrees minus 68 degrees is equal to 112 degrees. So this is 112 degrees. I hope that you understood this part. Problem number 3. If measure of angle A is 7x minus 11 degrees and measure of angle D is x plus 55 degrees, solve for measure of angle B, measure of angle C, and measure of angle D. If we look at the given, we can see that angle A and angle D are supplementary angles. So therefore, the sum of their measures is equal to 180 degrees. So measure of angle A plus measure of angle D is 180 degrees since they are supplementary. And measure of angle A is 7x minus 11 degrees plus measure of angle D is x plus 55 degrees. That is equal to 180 degrees. Simplifying, 7x plus x, that is 8x. Negative 11 plus 55 is positive 44. That is equal to 180 degrees. By the addition property of equality, 8x equals 180 degrees plus 44 becomes negative 44, or 180 degrees minus 44 degrees. So we have 8x equals 180 degrees minus 44 degrees. That is equal to 136 degrees. So to solve for x, we divide this by 8. So x is equal to 136 divided by 8. That is equal to 17 degrees. Now we have to solve for measure of angle B, angle C, and angle D. We know that the measure of angle D is equal to x plus 55 degrees, and x is equal to 17 degrees. 17 degrees plus 55 degrees, so we get 72 degrees. So measure of angle D is 72 degrees. To solve for measure of angle B, since angle D and angle B are opposite angles, then they are congruent. So since angle D is 72 degrees, then angle B is also 72 degrees. Angle A and angle D are supplementary. So what must be the value, or what must be the measure of A, so that when we add 72 degrees, the answer is 180 degrees. Or we just subtract 180 degrees and 72 degrees, and what we get is 108 degrees. So when we add 108 plus 72, that's 180. And angle A and angle C are opposite angles. and therefore they are congruent. Thus, measure of angle C is also 108 degrees. We're now down to the last problem. Given is quadrilateral EDCB, which is a parallelogram. If EF is 5y plus 13 and FC is 9y minus 23, what is the length of EC? The property of a parallelogram states that the diagonals of a parallelogram bisect each other. So therefore, we can say that EF is congruent to FC, or EF is congruent to FC, and therefore their measures are equal. So since EF measures 5y plus 13 and FC measures 9y minus 23, then we can say that these are equal. So we have, by the addition property of equality, 5y, positive 9y or plus 9y becomes minus 9y equals negative 23 minus 13. 5y minus 9y is negative 4y. Negative 23 minus 13 is negative 36. So to solve for y, we divide both sides by negative 4. Thus, we get y equals positive 9. The question is, what is the length of EC? Since EF is equal to 5y plus 13 and y is equal to 9. So therefore, EF is 5 times 9 plus 13. And 5 times 9 is 45. 45 plus 13 is equal to 58 units. So since EF is 58 units and EF is congruent to FC, therefore FC is also 58 units. So therefore, the length of EC is equal to 2 times 58, or that is 58 plus 58, and that is equal to 116 units. I hope that you learned from today's video. Thank you for watching, and please don't forget to like and subscribe our channel, which is TLC Math Made Easy. Thank you, and God bless everyone.